Hey everybody, so we're going to be starting a new section here talking about both the inner and outer planets in our solar system. You can see them up here on the board. If you have it, I would encourage you to take out your books. We are going to be starting on page 552. The section goes through 559, just starting to talk about the inner planets. And as we're talking about the planets of the solar system, it's really important to understand that a lot of these planets, in fact, most of them have been known about since ancient times. So we're talking about ancient Greeks, Persians, even Chinese astronomers that, without the aid of a telescope, were able to study the heavens, and they knew the skies so well. We're talking about the night sky, that they began to identify these little points of light that seem to be moving independently through the stars. I mean, imagine, looking up at the night sky, and I know you can't really see it here very well, but, just looking at these, thousands upon thousands of little points of light and be able to identify one of those and say, hey, that doesn't seem to be moving the way all the other dots are. Imagine looking up, and you can see, say, like the Big Dipper when you look up into the sky. And you know that the Big Dipper seems to move across the sky as time goes on. Today we know that's because the Earth is rotating on its axis. And we can see that all those stars are moving together, though. So even though they're moving through the heavens, the whole constellation is kind of moving together through the sky. But these ancient peoples knew the heavens so well that they could see that there were certain little dots of light that were just kind of moving independently through the sky. And they called those, or at least the Greeks called them, planets or planetos, it's the Greek word for wanderers, because they would seemingly wander through the heavens. All right, and so the planets that had been identified in ancient times, that's going to be Mercury, Venus, Mars, Jupiter, and Saturn. We'll talk about how Uranus and Neptune were discovered later, as well as Pluto, and why Pluto gets downgraded or demoted from a planet to just a dwarf planet. All right, we'll get there eventually, but for now we're just going to talk about the first four planets closest to the sun, also called the inner planets. All right. So starting on page 554, we're talking about Mercury first, okay? And Mercury, like all the other inner planets, they're going to have some things in common, okay? So Mercury, like Venus, Earth, and Mars, they all have hard, rocky surfaces. You can actually land on them and stand on them. Although you wouldn't want to stand on the wrong side of Mercury because you'd probably be cooked to death. So it is the closest planet to the sun. They're also much smaller in size than the outer planets. Mercury is going to be the smallest of the planets, while Venus and Mars are pretty similar, or excuse me, Venus and Earth are going to be very similar in size. And they're going to spin or rotate more slowly than the outer planets, except we're going to talk about one of the slowest rotations. That's going to be Venus. Has a very strange way of rotating on its axis. And their orbits around the sun are going to be really quick. Okay, so they're going way faster than the outer planets. And part of that is, in order to maintain a steady orbit, they have to be booking it around the sun. So if a planet were to orbit the sun too slowly, that orbit would begin to decay and it would eventually fall into the sun. Okay, so let's take a look at Earth. That is our home, a very remarkable planet in the solar system. One, because it is the only planet in the solar system that has liquid water at its surface. And this is one of the main reasons that Earth is capable of sustaining life. It's in what scientists refer to as that Goldilocks zone. So it's not too far away from the sun where it's bitter cold and frozen. It's not too close to the sun where it's way too hot. It's just kind of right there, right in the middle, right in this perfect region where you're able to have liquid water. In fact, most of the Earth's surface, about 70% of it, is covered with water. And the only planet that we know of to sustain life. Although scientists are looking for possible candidates of maybe, if not planets, moons that orbit planets that could be a possible place to sustain life, but Earth is the only one we know about so far. All right. So that's going to bring us on to Mercury. Mercury is about the same size as the Earth's moon. It's also a very similar kind of composition and appearance. If you were to take a look at images of Mercury's surface versus the moon, both are very gray, pockmarked with asteroid impacts. Okay, so Mercury has just been hammered with asteroids and meteorites over the years. The closest we've ever been to the surface of Mercury has been a probe that was sent out way back in 2011 to 2015. That's going to be the MESSENGER probe, and it brought back very detailed images of the planet's surface. So while Mercury does get incredibly hot on the daytime side, that's the sun, the sun-facing side, about 430 degrees Celsius. On the opposite side, as it's rotating, if you were to face away from the sun, because Mercury has almost no atmosphere, it's not going to be able to trap all that heat it's getting from the sun. And so nighttime temperatures will dip down to negative 170 degrees Celsius. So even though it's the closest planet to the sun, it's not necessarily the hottest. That award goes to Venus, which we'll talk about in a second. And the reason that Mercury is not the hottest planet is because of that very thin atmosphere. It's got almost no atmosphere whatsoever to trap any of that heat. So any heat it's receiving from the sun on the daytime side is just immediately going to bleed off into space on the nighttime side. So it is the planet in the solar system that does have the greatest temperature differences between the daytime side and the nighttime side. All right. So speaking of Venus, very little was known about it for many years, just partially because unlike other planets, it has a very thick atmosphere. So unlike the inner planets, such as Mercury or Mars, it's impossible to see through that dense, thick atmosphere to see the surface of Venus. And so it wasn't until certain probes were launched toward the planet that instead of using regular cameras, would actually map the surface of Venus by firing radar at the surface. And by doing so, scientists were able to get a topographical map of the surface of Venus. Only one probe has ever been able to make it down to the surface, and the reason is because Venus, as we said before, does hold the record for being the hottest planet in the solar system, and that is because of its incredibly thick atmosphere. So if you were able to stand on the surface of Venus, not only would you actually be crushed by the atmosphere itself, so the pressure is absolutely tremendous. But it's also because that atmosphere is going to be mostly carbon dioxide, which is a very powerful greenhouse gas. It is very, very good at trapping heat. So all that solar energy that's hitting Venus constantly is getting trapped within its atmosphere, and very little of it is bleeding off into space, which is why temperatures on Venus can even increase above that of Mercury. Even though Mercury is the closest planet, Venus is going to be the hottest planet. Okay, so below the picture of Venus itself, it's kind of hard to see from here, is one of our only images that's ever been taken from the surface of Venus by a Russian probe that was sent years ago. As soon as it landed on the surface, the probe itself quickly deteriorated, the heat became too much, and very quickly malfunctioned, just because the surface of Venus is so, shall we say, extreme. All right, so very little exploration has been done on the surface of Venus, even though in terms of its size, very similar to the size of Earth. It's just a very foreboding kind of planet, okay? One of the weird things about Venus is that that kind of sets it apart from other planets in the solar system is that it's actually going to rotate, it spins backwards from all the other planets in the solar system. So all the planets in the solar system, Uranus also has kind of a weird rotational pattern, but Venus is the only one that's going to turn completely backwards from all the other planets. And not only that, it's turning very, very slowly, all right? So because of that, a day on Venus, or the time it takes for Venus to make one rotation. Like for Earth, one rotation takes about 24 hours. All right, so the time it takes to go from day, spin around all the way around to the next day, that's 24 hours. For Venus, that's going to take about 243 Earth days to make one rotation, which is actually longer than a year on Venus. So if we define a year on Venus as the time it takes Venus to orbit the sun, the orbit of Venus only lasts 226 days, whereas its rotation is 243. So this is why scientists say a day on Venus is longer than its year, right? Just because it's rotating so slowly and also in the wrong direction. Okay, so now we're going to go on to one of the other planets in the solar system that we know most about, and that's going to be planet Mars. Okay, so Mars, one of the reasons why it's so often visited by probes, and not only by probes but also rovers, is because it has a slightly more habitable surface. When I say habitable, I mean obviously human beings couldn't survive there without some kind of spacesuit. But at its equator, temperatures on Mars would be comparable to certain places here on Earth. All right, even though it is much farther away from the sun than the Earth, temperatures do get very cold there. Partly because it has a very thin atmosphere, not quite as thin as Mercury's. But its atmosphere, which is mostly carbon dioxide, is going to be about 1% as thick as the Earth. So temperatures are going to get very, very cold on Mars. So like the Earth, Mars is actually tilted on its axis. And just like on Earth, that's going to mean that Mars has certain seasons to it. In other words, there's going to be certain parts of Mars, either its northern hemisphere or southern hemisphere, that are going to be facing either toward the sun or away from the sun at certain times of the year. What's going to happen here is that Mars, at its poles, does have, or seems to have, ice caps. Now, these ice caps are kind of a mixture of different materials. So some of it, scientists do believe, could include water or water ice. The vast majority, though, is going to be carbon dioxide. And frozen carbon dioxide, basically, here on Earth, we refer to that as dry ice. But that's basically mostly of what's forming at the poles of Mars. So if you look and see, you can see, like Earth, there's this frozen, shall we say, polar activity going on Mars. And depending on the season, which side of Mars is tilted away or toward the sun, those polar caps will either grow or shrink. Now, the thing to remember about carbon dioxide, or CO2, is that it never becomes a liquid at certain temperatures. So it can go from an ice to a gas very quickly. And what that's going to result in is high winds on Mars. So Mars is a very foreboding planet. It's very cold, very windy, and just a large hunk of dry dust. And the thing that's going to give Mars its reddish sort of tint, the reason it's called the red planet, is because Martian soil is mostly just it's iron, or rather iron oxide, which here on planet Earth we know as rust. The planet has literally rusted. It's surrounded by this material. So that's what's going to give it its reddish color. Now, some interesting features that we see on the planet Mars is, like the Earth, Mars does have moons, well, 2 moons to be specific. They're very small, much, much smaller than the Earth's moon. In fact, one of the moons is orbiting at such a speed that its orbit is actually decaying, and scientists do predict that at some point, perhaps maybe in the next few million years, that the smaller of the 2 could crash land to the surface of Mars. Another interesting feature we see is that Mars, as far as scientists know, has the largest volcano in the solar system. So the volcano is an ancient extinct volcano. It's no longer active, but it's referred to as Olympus Mons, and about the size of the state of Missouri. So it's absolutely massive, and kind of puts our Mount Everest to shame. It is huge. All right. So here we have kind of a closer up view of Mars's two moons. Now, you notice like our moon, they're not like nice round spherical shapes. They're kind of weird oblong. And part of the reason is that in space, in order to have that nice round shape, scientists know that only objects of a certain size are going to be more spherical. So these are actually, scientists believe, possibly meteors or asteroids that were passing within a certain distance of Mars, and Mars was able to just hold on to these objects with its gravity, and they entered orbit around Mars. They're not really large enough to have accumulated enough material to be that nice round shape that we think of when we think of the Earth's moon. Okay? And this is going to be true of a lot of different objects that we find out in space. So from the asteroid belt to what's known as the Kuiper belt or the Oort cloud, there are all kinds of different rocky metallic objects that occupy the vast reaches of our solar system. Okay, so that's going to do it for the inner planets. We are going to be moving on in just a bit, so look out for the next video talking about the outer planets. So that's going to include Jupiter, Saturn, Uranus, and Neptune, and sorry, Pluto, you don't count anymore. And we'll talk about why that is. All right, in the meantime, I'll see you later.